Section 8.1, we're discussing systems of linear equations in two variables. This is not really unique to pre-calculus. This is review of algebra, so this will give you an opportunity to do a little bit of review of material that you've seen before. We're going to start with talking about systems of equations. The solution to a system of linear equations in two variables is the ordered pair xy of their point of intersection. So in this section, in section 8.1, we're only working with linear equations in two variables. That means that we're working with lines, and we're only working with two lines at a time. There are three possibilities that can occur when solving a system of equations in two variables. The first one is the one that we'll see most often. We might have two straight lines and they can intersect in exactly one place, giving us an ordered pair for our solution. We refer to this situation as an independent system. The second scenario that can occur is you might have parallel lines. If you have two equations that are giving you parallel lines when you graph them, this system does not have a solution, and we say that it's inconsistent. And then the third scenario that can happen is you might have two equations that both represent the same line when they're graphed. This one would have infinitely many solutions, and we call this a dependent system. So those are the three possibilities. For our purposes, we're most interested in this first scenario. We're going to be looking at some applications in this section, but before we do that, there are two methods that we'll be using to solve systems of linear equations. There are really three methods that you can use. The first one is the graphing method, and the graphing method works fine if you're using the graphing calculator. If you can find the point of intersection, if your calculator shows you the point of intersection of the two lines, then that's good. Algebraically, we can also solve a system of equations using the substitution method or using the addition, or sometimes it's called the elimination method. I'm going to do an example using the substitution method first. In example 1, we want to solve the system of equations y equals 2x plus 1 and also 3x minus 4y equals 1. So we're solving these at the same time. This is just my preference, but I like to put a little symbol around the two equations just to indicate that I'm working with these at the same time. Now, as far as how we're going to go about solving this, the substitution method works really well if you already have one of your equations solved for one of your variables. You'll notice the first equation is solved for y. So that makes it easy to substitute the 2x plus 1 into the second equation in place of the y. Making the substitution will give us 3x minus 4 times, and then when we come to our y, we'll put our 2x plus 1 in. And that's equal to 1. So you'll notice we now have all x's. There are no y's that need to be solved for, so we can solve this for x. We'll distribute our negative 4, so we have 3x minus 8x minus 4 equals 1. And then combining like terms, I get negative 11x. Oh, I'm sorry. I think I messed up. That should be positive 3x, excuse me. I don't think I've got any white out though. Sorry about that. Alright, that's a positive 3x minus 8x minus 4 equals 1. So 3x minus 8x gives me negative 5x. At least I caught my mistake, because I don't have you guys to tell me when I mess up one on the videos. So I've got negative 5x minus 4 equals 1. Add 4 to both sides. Negative 5x equals 5. And then divide by negative 5, I get x equals negative 1. But remember, we're looking for an ordered pair. So we got the first variable. To get the y, we'll do the back substitution step, where we take our negative 1 and substitute it back into one of these original equations. You're free to put it in either one of these that you want. I want to put it in the first one because I think it's going to be easier to put it into the equation that already happens to be solved for y. So I'm going to put my negative 1 into that first equation in place of my x, giving me y equals 2 times negative 1 plus 1. And that gives me a value of y equal negative 2 plus 1, or negative 1. So my ordered pair, my solution is the ordered pair negative 1 comma negative 1. And that's my answer. For example 2, we're going to use the addition method. I may accidentally refer to this method as the elimination method sometimes because most textbooks do call it the elimination method. But they're asking us to use the addition method. So what this is asking me to do is to first make sure that I have my equations set up so that I've got an x column, I should have a y column, and then I've got my equals, and then I've got my constant on the other side of the equals. Make sure that they're set up in this order. Once they are, we're going to manipulate these equations so that when we add the two equations together, one of our variables needs to be eliminated. One way that we might do this is that we can multiply the top equation on both sides. Of course, you can multiply by anything you want to as long as you keep it balanced. Let's multiply the top equation by what would be an easy way to eliminate one of these variables. Let's first decide which variable we would like to eliminate. Do we want to get rid of our x's or do we want to get rid of our y's? It's going to be easier to eliminate the x's because the top x has a coefficient of 1. So what would I like to have sitting in front of that first x so that when I add these together they cancel out? Since this one is a -3, let's put a +3 here. So we can get a +3 here if we multiply that first equation on both sides by 3. So this will give me 3x minus 12y equals -9. And then my second equation will stay just like it is. But now I can add them together. The x's cancel. -12y plus 5y gives me -7y. -9 plus 2 gives me -7. And then I can solve this easily for y if I divide both sides by this -7. That's going to give me y equals 1. So now what do? I've got y. I need to find my x so I can do my back substitution step. I could put 1 into either of these equations. I'm going to put it into my first one for y. So I'm going to have x minus 4 times 1 equals -3. So x minus 4 equals -3. If I add 4 to both sides, I will get x equals +1. My ordered pair for my answer is going to be 1, 1. Okay, it was pure coincidence that both of my examples gave me the same x and y values. So the first one was -1, -1. My second example was +1, +1. But that was just coincidence. All right, so that's how the substitution method and the addition methods work. And now we're going to look at some word problems that we can use these methods to help us solve. Example 3. We have 2 DVDs and 3 CDs cost $78. 1 DVD and 4 CDs cost $74. What is the cost of a DVD? So we're going to use a system of equations to help us to solve this problem. What are we being asked to find? They want to know what is the cost of a DVD. And of course we're also being given information about CDs. So let's let x equal the cost of, they're asking us to determine the cost of a DVD, so I'm going to let that be my x. Let x equal the cost of a DVD. And I can let y equal the cost of a CD. I can use this to set up my equations. I know that 2 DVDs and 3 CDs cost $78, so I can get an equation from that statement. I can write that as 2 times x, because x was the cost of a DVD, plus 3 CDs, so that would be 3y, equals, they cost $78. My second sentence will give me a second equation. 1 DVD, so that's x, and 4 CDs, so plus 4y, cost $74, so equals 74. Here's my system of equations. So this one is set up nicely for the elimination method. You'll notice that it's pretty easy to eliminate these x's. We can multiply that bottom equation by -2. So if I do that, I've got 2x plus 3y equals 78 for the first equation. And then my second one will give me negative 2x minus 8y equals, and I need to do negative 2 times 74. And I got to see what that is. It's going to be negative, and 2 times 74 gives me 148. So negative 148. I can add those together. The x's cancel. I get negative 5y equals negative, how much is that? I think it's negative 70. Yeah, negative 70. Divide by negative 5, and y equals, how much is that? 14. So that's telling me that the cost of a CD is $14. What are we asked to determine? We were asked to find the cost of a DVD. So to get the cost of a DVD, I need to do my back substitution, put 14 back into one of these original equations. I'm going to put it into that second one because it looks a little bit easier. So I'll have x plus 4 times 14 equals 74. And then from there I can do my calculations. 4 times 14 is 56, so x plus 56 equals 74, and then subtract. X equals 18. Okay, so we always have to make sure that we answer our original problem. They were asked to determine what is the cost of a DVD. Remember, we let x equal the cost of a DVD, so our x would give us our answer of $18. So we could say a DVD costs $18. And that's it for that problem. So the systems of equations are really nice for helping us solve these word problems. Example 4. Ruby invested a total of $100,000 in 2 mutual funds at the beginning of 2008. At the end of 2008, she lost 32% of the amount invested in the Fidelity Balanced Fund and lost 50% of the amount she invested in the Fidelity Value Fund. If her losses totaled $42,800, how much did she invest in each fund? So a lot of times we can use this question to help us determine how to set up our X and our Y. We're being asked how much did she invest in each fund. So I'm going to let X equal the amount invested in the first fund. The first one was Fidelity Balanced Fund, and then the second one was Fidelity Value Fund. I don't like that those names are so similar. I'm going to call the first one the Balanced Fund. Okay, and then I'm going to let Y equal the amount invested in the Value Fund. It would have been nice if they had just given them completely different names, but they didn't do that. Now, how can we set up a system of equations with this information? Remember, she invested a total of $100,000. Some of it went into the first fund and some of it went into the second fund. So that means that if we take the amount invested in the first fund and add it to the amount invested in the second fund, the total is going to give us that $100,000. So that gives me my first equation. I have x plus y equals 100,000. I can get a second equation by reading the rest of the problem. She lost 32% of her amount invested in her Fidelity Balanced Fund. So that means 32% of the X that we described as the amount invested in that fund. So we can take 32% of X, or 0.32X. She lost that much, and she also lost 50% of the amount she invested in her value fund. So that's going to be 50%, or 0.5 times Y. And she had a total loss of $42,800. So the amount that she lost from the balanced fund plus the amount she lost from the value fund is equal to that $42,800. And this gives us a system of equations. If you've got 2 variables, you need to have at least 2 equations, and you've got that. So how are we going to solve this now? If you want to do elimination method, that's fine. You'll be working with a lot of decimals if you do that, probably. Or if you want to, you might also solve your first equation for one of your variables. So let's say if I solve that first equation for y, I could write it as y equals 100,000 minus x. And then I can substitute this into my second equation for my y here. So I can say that 0.32x plus 0.5 times 100,000 minus x equals 42,800. And I'm going to let you take a minute and solve that for x. So why don't you go ahead and pause your video, solve that equation for x, and then we'll see what you got. Alright, so let's see how you did. I've got 0.32x plus 0.5 times 100,000, that's 50,000, minus 0.5 times x equals 42,800. Combined in like terms, 0.32x minus 0.5x gives me negative 0.18x. And I want to subtract 50,000 on both sides, so that's going to give me negative, let me double check, I don't remember. I think it's 7,200. Yep, negative 7,200. Divide both sides by 0.18, and you will have $40,000. And I'm sorry, I'm off the screen. Here you go. I got $40,000 for x. Alright, now what were we asked to determine? They wanted to know how much did she invest in each fund. So we found that x was $40,000. That means she invested $40,000 in that balanced fund. So $40,000 in her Fidelity balanced fund. Alright, so if she invested $40,000 in her balanced fund, how much did she invest in her value fund? Well, if x is 40,000, y has to be 60,000 because they have to add up to 100,000. So we would have $60,000 in her Fidelity value fund. And that's it for that one. So 40,000 in the Fidelity Balanced Fund, 60,000 in the Fidelity Value Fund. In example 5, we're told that the Springfield Zoo has different admission prices for adults and children. When Mr. and Mrs. Weaver went with their 5 children, the bill was $33. If Mrs. Wong and her 3 children got in for $18.50, then what is the price of an adult's ticket and what is the price of a child's ticket? So, like the previous problems, the question that they're asking is going to help us determine how to choose our X and our Y. And we're being asked what is the price of an adult ticket and what is the price of a child's ticket. So I'm going to let X equal the price of the adult ticket and Y will be the price of the child's ticket. Okay? And I'm also given the information I need to set up my 2 equations. We are told that Mr. and Mrs. Weaver, so that's 2 adults, went with their 5 children. So 2x and 5y, and then the bill was $33. So that gives us an equation of 2x plus 5y equals 33. Then we're told that Mrs. Wong, so 1 adult, went with her 3 children and got in for $18.50. So that gives us 1x plus 3y equals $18.50. So we have a second equation. Alright, so we'll use, this one is set up nicely for the elimination method. I could easily eliminate the x's if I multiply the second equation by -2. So that's going to give me my first equation staying the same, 2x plus 5y equals 33. Second equation, I have -2x minus 6y equals negative, and then whatever 2 times 1850 gives me, that would be negative, how much? find a calculator that works. Is it 37? That's what I want to say it is. Yep. Okay, so negative 37. Adding these together, the x's will cancel out. Then we'll have negative 1y equals negative 4. So y equals positive 4. And then what are we being asked for? We're asked for both prices, the price of the adult ticket and the price of the child's ticket. So we need to put the y back into one of our original equations. I'm going to put it into the second one just because it looks a little easier. So I'm going to have x plus 3 times 4 equals 1850. And that's going to give me a price of $6.50. So that tells me that the adult ticket, costs $6.50 and the child's ticket is $4. And I apologize that that's not showing up. So here's my work, and then my answer, the adult ticket was $6.50 and the child ticket was $4. Alright, so you should have enough information to be able to do, or at least get a good start on the problems in section 8.1. This is a nice short section, and we've got 2 more sections left after this, so we will work on these some more in class. Thank you.